Hi folks, let's do another tree problem today. Today is the tree day, I would call it. All the problems will be related to trees because trees are fun to be around and trees are fun to go and watch when you're bored with coding. And even though here we are talking about software trees, but the trees in real life are equally interesting. So, coming back to the problem here, it's Leetcode 653. It says two sum. So we have seen two sum before, and we know that that one was for an array. That can we find the two elements, indices of the two elements in an array whose sum is equal to a given target. But here we don't have to find the indices. We just have to return true or false. It says given a binary search tree and a target number, return true if there exist two elements in the BST such that their sum is equal to the given target. So the example given here is 536247 and the target is 9 and the output is true because 5 plus 2 is 7. The 5 here and then this 2 is adds up to the 7 2 here and the 7 here adds up to the given target of 9. So that is true. The answer is true. Now let's take example 2. And target is given to us is 28. So there are no two numbers in the tree here which add up to the target 28. So if you take, for example, 5 plus 3, 8, 5 plus 6, or all the possible combinations you could try, but you wouldn't be able to find two numbers that add up to the given target 28. So what else have we seen here? There are no other conditions. So let's try to solve this in Python. And the two approaches to solving tree problems. One is the recursive approach and the other is iterative approach. Now, in this case, we just have to keep track of all the elements that we find. We might put them in a some kind of a data structure. We don't know what it is. Should it be a dictionary? Should it be a set? But in the case of arrays, the two sum problem for arrays, we did use a hash map or the Python dictionary, and that's because we had to return the indices, and our hash map was basically having a key value pair. The key was the value of the element in the array, key was the element in the array, and the value was the index of that element in the array. But here we don't need index. So should we add a so should we use a hash map? Probably not. I would say we can get away this time with just a set, which is an interesting data structure in Python because a set allows us to have elements that are unique. So let's use sets. So we can start by initializing empty set, and then instead of recursion we would actually use a label order traversal kind of approach, which is kind of an iterative approach, putting the things in the queue, putting all the nodes in a queue and then dequeuing them one by one. Basically, we start by putting the root and then we dequeue root, put its children based on whether any non-null pointers are there, and then we basically iteratively follow that approach. Why not use recursion? You might ask me that question. The reason I would say recursion is kind of a little bit not as clean in this approach is because for this problem, because we have this local variable temp set. So if we are going to solve this problem in a recursive way, we may need a global data structure so that that's common for all the functions that we call. So let's just use the label order iterative kind of approach. So temp set, and then we say q equal to, So we use Python being such a awesome language gives us queues through their list data structure. So we can say we can initialize a queue like that, which is just a list, and then we say queue.append root, and then while queue is not empty. That's like saying while queue not empty. So while queue, we would dequeue the element from the front of the queue, the first in first out kind of approach. We'll say queue.pop, and the way you pop from the front instead of the last item put is by saying the index 0. So basically it will pop from the front of the queue. So if a queue was something like this, imagine you had a queue like 5, 7, 9, 8, 9. Now at that point q.pop would actually pop 5, not 9s. Q.pop 0 would actually pop the element at index 0, which is 5, or the front of the queue. So that's node. Now what we do is we see if target minus node dot val in temp set, and if it is, we are set and we can just return true. And otherwise, when we keep falling through the code, we see that we just say temp set dot add node dot val. So we keep adding the nodes that we are seeing, the values of the nodes that we are seeing into the set. Now what we need to do is that if node dot left, then we q dot append node dot left, and if node dot right, in Python, usually they don't put these brackets. So, but I'm still I'm still using the C approach of using brackets around the expressions in a very prolific manner. So that's why I keep putting those. So let's see now q.append node.write. So if we walk through this whole loop and we never return true, that means we can pretty much return false here. So let's see if this works. So we have a problem here. He's saying there's no such thing as target, and that's absolutely right, because the value of the or the name of that target variable here is actually k. So let's change that, and hopefully this should work now. Awesome. So that's accepted. Now let's see if when we submit it, all the test cases pass. That's great. So there we have it. It says 97% of Python 3 online submissions for twosome. Wow, that's cool. So there you have it. Basically, Leetcode problem where twosome again this time, but input is a BST instead of an array. And I would say that what are the gotchas for this problem? I would say the biggest thing is to decide to use iteration instead of using recursion here. I would say that's really interesting, because otherwise you would have had to use a global variable or something like that for the set. If you Apart from that, it sounds fairly straightforward. But if this were asked to somebody in an interview, uh, how would they immediately come up with these insights is something that remains to be seen. But in any case, it was an interesting problem. I had fun doing it. I hope you had fun looking at the problem and doing it on your own also. So until next time, adios. Have a great time coding. Bye bye.